Here is the unit circle with the special right triangle degrees labeled around it. Now remember, degrees is just the way that we are used to measuring around a circle. 0 degrees, 360 degrees. Well, there's a different way that you can measure around the circle. It is called radians. Here's a unit circle, but this time all the degrees have been taken out. We are going to replace them with radians. Remember, radians is just another way of measuring the distance around the circle. If you notice at the bottom right hand corner, there is a formula. C equals 2 pi r. If you remember, that is the formula for the circumference of a circle. We are going to use that to fill in the radians around the unit circle. We'll start off with 0 radians. It's the same exact place as 0 degrees. Now let's go ahead and go all the way around the circle. Applying the formula C equals 2 pi r, but this time we're going to replace the r with 1 because this is a unit circle, so the radius is 1. If we replace r with 1, the distance around this whole circle is 2 pi. Now go ahead and look at where 180 degrees used to be. If the distance around the whole circle is 2 pi, then what is the distance around half the circle? 1 pi. Now look at where 90 degrees used to be. That would be half of a pi. And then look at where 270 degrees used to be. That would be 3 pi over 2, or 1.5 pi. Okay, now let's fill in the middle ticks, the 45, 45, 90 degree triangles. All right, remember where 45 degrees was? It was right in the middle between 0 and 90 degrees. In this case, the middle between 0 and pi over 2 is pi over 4. Let's go over to the second quadrant. What's in the middle of pi over 2 and pi? 3 pi over 4. Let's go to the third quadrant. Let's find that middle. 5 pi over 4. And then the fourth quadrant. Take a guess. It is 7 pi over 4. Now, if you're having a hard time remembering these or knowing how I got them, there's a very easy way to do it. If you just count. Starting with 0, if you go up, you have 1 pi over 4. If you continue going up to the green, you have 2 pi over 4, but that reduces to pi over 2. So again, 0, 1 pi over 4, 2 pi over 4, reduce. The next one is 3 pi over 4. Continuing on, you have 4 pi over 4, reduces to 1. And then you have 5 pi over 4, and then 6 pi over 4, reduce, and then 7 pi over 4. And then finally, 8 pi over 4 reduces down to 2 pi. Okay, so if you have a hard time remembering, it's just 1 over 4, 2 over 4, 3 over 4, 4 over 4, 5 over 4, 6 over 4, and 7 over 4. Now let's fill in the 30, 60, 90 angles with their radians. The first tick mark that's missing is 30 degrees. To find it, you should know that it is 1/6 of pi, or pi over 6. The next one up, 2 pi over 6, but that reduces down to pi over 3. The next tick over, 2 pi over 3, 5 pi over 6, 7 pi over 6, 4 pi over 3, 5 pi over 3, and 11 pi over 6. Again, those are hard to remember. So the shortcut way to label them is going by 1/6. Let's go together. Starting here, we have 0, 1 pi over 6, 2 pi over 6, but reduce it, 3 pi over 6, but reduce it, 4 pi over 6, reduce it, 5 pi over 6, 6 pi over 6, reduced, 7 pi over 6, 8 pi over 6, reduce, 9 pi over 6, reduce, 10 pi over 6, reduce, 11 pi over 6, and then 12 pi over 6, reduce. There is a formula to convert from radians to degrees. The formula is theta equals 180 divided by pi times x. This little symbol is theta. It is a Greek letter, and we will use it to represent degrees. The x will be used to represent radians. Let's do an example. Here we have 5 pi over 3 radians. To convert it to degrees, we just plug in 5 pi over 3 into the x, so that we have theta equals 180 over pi times 5 pi over 3. Use a little bit of algebra 1, cancel out the pi's, the 3 reduces with a 180, you have 60 up here. 60 times 5 is 300 degrees. All right, let's do another example. Let's convert pi over 4 into degrees. Same thing. 180 divided by pi times pi over 4. The pi's cancel out. 180 divided by 4 is just 45 degrees. All right, one more example. Let's do negative 2.5 pi. Same thing. 180 divided by pi times negative 2.5 pi. The pi's do cancel out. And then 180 times negative 2.5 is negative 450 degrees. There you go. There's also a formula to convert from degrees to radians. There it is. X is the radians equals theta times pi divided by 180. All right, let's go ahead and use that formula to convert 180 degrees. Here we go. We just plug in 180 degrees to the theta. Reduce. The answer is pi. All right, another example. Let's go ahead and plug in 15 degrees into the theta. If we reduce properly, we should recognize that this reduces down to pi over 12. And then finally, let's do negative 275. Reduce it down properly, we should get negative 55 pi over 36. Good. Let's do an example in degrees from last section. Let's find sine, cosine, and tangent of 60 degrees. All right, try to remember where 60 degrees is on the unit circle. There it is. It makes a right triangle. The long leg is radical 3 over 2. The short leg is 1/2. Now, to find sine of 60, remember, sine is the opposite side, radical 3 over 2. Cosine is the adjacent side, 1/2. And then tangent was opposite over adjacent. That's radical 3 over 2 divided by 1/2. Remember, to simplify that, you just take the denominator and multiply it to the tops using this reciprocal, and then simplifying it to get radical 3. Let's do an example in radians. Let's go ahead and find sine, cosine, and tangent for pi over 4. Without converting pi over 4 into degrees, let's try to remember where pi over 4 is. That is 1 pi over 4, right there. Knowing that, we have that side is radical 2 over 2, and then the bottom side is radical 2 over 2. Sine is the opposite side, radical 2 over 2. Cosine is the adjacent side, also radical 2 over 2. Tangent is opposite over adjacent. Radical 2 over 2 over radical 2 over 2. Simplify, you should get 1. Here's our last example for the day. Let's find sine, cosine, and tangent for 11 pi over 6. Now, 11 pi over 6 is not the easiest one to remember on the unit circle, so let's count together. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. There it is on the unit circle. There's our triangle. There's that side. Notice it is negative 1/2 because it is going down. And this one's still radical 3 over 2. Now we can do the problem. Sine of 11 pi over 6 is the opposite side, which is negative 1/2. Cosine 11 pi over 6 is adjacent, which is radical 3 over 2. And then tangent is opposite over adjacent. There it is, negative 1/2 over radical 3 over 2. You have to do a fraction over a fraction, which means you take the denominator, multiply it to the top with the reciprocal to get 1 over radical 3. Now, here's another thing. You are not allowed to have a radical in the denominator as your answer, so we have to rationalize. The way you rationalize is you multiply the 1 over radical 3 with the radical 3 to the top and the bottom. And that gives you radical 3 over radical 9, and of course we know what radical 9 is. It's just 3. So our final answer is radical 3 over 3. That is all we have for today.